synthesis of N-butyl bromide starting from N-butyl alcohol. Your reactant would be N-butyl alcohol and a source of bromide ion, and you'll be synthesizing butyl bromide or 1-bromobutane. So this is the reaction. This is an N-butyl alcohol or 1-butanol. You'll be adding sodium bromide and sulfuric acid to it, and this combination, sulfuric acid is a catalyst, and so this is a source of bromide. So your product would be N-butyl bromide or 1-bromobutane. Now this is a substitution reaction or SN reaction. SN reactions are those reactions in which one nucleophile goes out and the other nucleophile comes in. So one bond is broken and a new bond is formed. So it's a substitution reaction. And with respect to the mechanism, there are two kinds of nucleophilic substitution reactions. Okay, overall reaction is the same, but by with respect to the mechanism, there are two categories. One category is called SN2. S means substitution, nucleophilic, and 2 stands for bimolecular. And here, nucleophilic substitution, unimolecular. What does that mean? It means that a reaction may take place in a single step or in more than one step. But the step that is slow is the only one that's kinetically important. Okay, so we need to focus only on that step. There may be other steps, but not which are fast steps. We are not concerned with that. The kinetics is concerned with the slow steps. So here in SN2 reaction is just actually in the slow step there are two chemical species that react together. In other words, it takes two to tango. In other words, right? That means that two chemical species, they come together to make a new bond. Okay, so there's only one single step in this reaction, normally, which is represented by XY. There's a bond between X and Y. Then this bond will be broken, and nucleophile will come in, and it will attack X. So XY is called a substrate. Substrate is any molecule that has the electrophilic center in it, right? So this is a nucleophile. This is an electrophilic center here, and so nucleophile makes a bond between itself and X to make this new bond form, and Y comes out, which is called the leaving group. So leaving group is also a nucleophile, but it is a weaker nucleophile. This one is a stronger nucleophile. Alright, so stronger nucleophile displaces a weaker nucleophile in a single step here. So here, remember there are two lone pairs on the oxygen of the alcohol, and alcohol is protonated by what? Protonated by sulfuric acid. So sulfuric acid protonates it to generate oxonium ion. Oxonium ion then gets attacked by bromide, and this bond leaves to give you water and butyl bromide. So this is a new bond form, right? So it's a two-step reaction. And the first step is protonation. Protonation is a very fast reaction, so we disregard it. But however, in this step, which is a slow step here, this is the SN2 step. There are two chemical species that are reacting together. That's why it's SN2 reaction. Alright, so what you do is you measure 17 grams of sodium bromide, 10 ml of N-butyl alcohol, and add 17 ml of water in it, and then you add concentrated sulfuric acid. And then after that, you basically set up the experiment. You are basically adding all these things in a 100 ml round water flask, and then you attach a condenser, water condenser to it. Water coming in from the lower end and leaving from the upper end, then the top of the condenser is fitted with a thermometer adapter through which a tube is green, a small tube. It could be a plastic pipette. You can attach it or goes to it, and then this tube is connected with a hose to an inverted funnel. That's the purpose of that. because we'll be generating sulfuric acid, and sodium bromide will be generating HBr, hydrogen bromide gas. And that's kind of dangerous and corrosive gas. So this is optional. If you want to do it, that's good. If you don't want to do it, just leave it open. That should be fine too. Many labs don't do it, so that's fine. That's okay. All right. So what you do is you start heating it with a hot plate and start boiling it. You know, you keep the setting of the variac around 70, and it will start boiling. And boil for about 15 minutes, 15 minutes to 1 hour, something like that. And then you should see that the product is formed. How do you know that? Because you can see two layers right here in the flask. You will have two layers. The upper layer would be the N-butyl bromide, the product formed, and the lower layer would be just sulfuric acid. Okay. All right. So once you are after 15 minutes, you just want to cool the flask, and now you have to do the rest of the workup with using a separatory funnel. So what you do is basically you make sure stopcock is closed, and you transfer the entire, after the reaction, the entire liquid mixture, which will be two layers. You can basically transfer those two layers into this separatory funnel. Many people just call it sep funnel for short. It's a very common thing that you have it in your kit. Okay, so this is the separatory funnel. So since this is closed, so you will have two layers. This layer would be N-butyl bromide, your product, and you will have another layer down at the bottom layer. This will be sulfuric acid, concentrated sulfuric acid. Now you are not interested in the lower layer. This layer you need to get rid of it. Okay, that's very easy. You just open the stopcock and basically you remove the lower layer. Make sure you keep it open. Don't close it. Don't put a stopper over there. So drain off the lower layer. When the lower layer gets on here, then immediately arrest it. You are interested only in this one, sodium bromide. I'm sorry, the butyl bromide. Now, butyl bromide may have some butyl alcohol in it, some leftover. May or may not, okay? May have, but so what we do is basically you want to wash this with sulfuric acid, 9 molar sulfuric acid. 9 molar is half as strong as the concentrated, okay? So 9 molar, you add 9 molar sulfuric acid and then you shake it. What's the purpose of this sulfuric acid? To absorb any starting material, which is alcohol, butyl alcohol. But again, after shaking and venting, you drain off the lower layer, 9 molar sulfuric acid. Okay. Then, what you want to do is you want to wash it with water. Okay. Again, you add water. Add water to it. Each time you must save this layer, this purple layer. Okay, that's your product. You add water. Now, water is. Be careful about water. Water is lighter than your product. So this time, your product will be lower layer, and so let the two layers separate. And this time now save this layer. So you drain it into a clean flask, and your here this will be your butyl bromide. And keep the upper layer, which is just water. You can discard that. Now this one has some acid to it. Remember, it has seen concentrated sulfuric acid, it has seen 9 molar sulfuric acid. There must be some acid in there, a little bit of sulfuric acid, a little sulfuric acid. You want to actually get rid of that sulfuric acid by adding a base. A base is a weak base, a baking soda, sodium bicarbonate. Sodium bicarbonate is NaHCO3. Sodium bicarbonate solution, saturated. So what you do is basically you put this thing back into the separatory funnel, close it, and then you add some sodium bicarbonate solution. This is a base. This will get rid of this sulfuric acid. It will neutralize it. So you add this one and then shake it. This time what happens is that sulfuric acid and sodium bicarbonate, they react together to give you carbon dioxide. So make sure that you vent the separatory phenol by inverting it, okay? Because you don't want to get pressure of carbon dioxide in water. Anyway, so after that, again, the lower layer will be your product and the upper layer would be your sodium bicarbonate. Okay, now you drain the lower layer and basically sodium bicarbonate is saturated solution in water. So now you have butyl bromide and a little bit of water in there. Okay, and hydrosodium sulfate, anhydrous means anhydrous, right? It's dry. When you add sodium sulfate to it, it will absorb a little bit of moisture that's left in the butyl bromide layer. Okay, it will not do anything to your butyl bromide. It will just get rid of the moisture. Okay, so you leave it there for about 5 minutes, and then you pour the whole thing, which is the butyl bromide actually, pour it into another clean pre-weighed flask. It could be beaker, it could be flask, right? And pour it and find out the mass of that. And once you know the mass of butyl bromide, then you can find out the percentage yield. Okay. Remember, you need to have two-dimensional equations, one for the sodium bromide and the other for butyl alcohol, and find out the limiting agent, and then you can calculate the percentage yield. Okay, bye-bye.
We are in the lab now, and I want to introduce to you some of the reactants that will be used in this lab. This is 1-butanol or N-butyl alcohol. This has the hydroxyl group. This is the substrate, and in order to do the reaction with it, we need a bromide source. So the bromine source is the salt sodium bromide. Sodium bromide furnishes the bromide ions. However, bromide ions cannot really displace the hydroxyl group of the 1-butanol, because hydroxyl group is a very poor leaving group. In order to make it a good leaving group, we need an acid source, sulfuric acid. So sulfuric acid will be using to protonate the hydroxyl group of the 1-butanol. So we need to add things to it. So in order to, this is a powder funnel. We can add powders through it. This is the long stem funnel to add the oils or liquid chemicals. This is the round bottom flask, 100 ml, and it has a boiling chip in there to ensure that the boiling goes smoothly. This is the condenser, water condenser. It is linked with, it is hooked with two Tygon tubing, two pieces of Tygon tubing. The lower piece of tubing lets the water enter into the condenser, and the upper tubing allows it to exit. So we are basically cooling the jacket in the condenser. Now we add the first reactant, sodium bromide. This is water, 14 ml water or 17 ml. This goes into the flask, and the water actually is used as a solvent. It is not one of the reactants. So basically you swirl it. Swirling is circular motion of the flask, not shaking. It's not shaking, it's swirling. So now you add the second reactant, N-butyl alcohol or 1-butanol. We add it. However, butyl alcohol doesn't react with the sodium bromide. As I mentioned to you, bromide is a good nucleophile, but it cannot displace the hydroxyl group, because hydroxyl group is very difficult to displace. So we need a protonating source. For that we need the we need to add sulfuric acid. So make sure you basically, before adding sulfuric acid, you lower the iron ring and make sure that the round bottom flask fits snugly with the help of a keck clamp. The blue is a keck clamp that ensures that the fitting is snug. You elevate the iron ring and make sure it fits into the socket of the heating mantle. By the way, this flask has been cooled in ice before adding sulfuric acid. Because sulfuric acid and water, they react in an exothermic reaction. So we want to make sure that we add sulfuric acid to a pre-cooled solution, number one. Number two, we add sulfuric acid very slowly. Maybe 1 ml at a time, and add slowly till you add all 14 ml of sulfuric acid. When you have finished adding, you can note that the flask that was pre-cooled has become hot. You can touch it and feel the heat, so you know what happens when sulfuric acid is added to water. It's an exothermic reaction. Okay, now you're ready to boil. You set the variac at about 70 setting. You turn it on, and now you wait for about 50 minutes for the reaction. The reaction will boil and it will reflux. Refluxing means that the liquid at the boiling point, the liquid is converted into vapor. The vapor try to escape, and as they go through the condenser, they get cooled and they condense and they go back into the flask. That way you don't lose the liquid. So we wait for 50 minutes. After this, the reaction will be complete. Now we have completed the reaction and we are ready to do the workup. Workup is a process by which you isolate the desired product from the reaction mixture after you have completed the reaction. So in this case, the workup would be isolation of N-butyl bromide, which is the product. You can see there should be two layers in there. The upper layer should be butyl bromide and the lower layer should be concentrated sulfuric acid. You can still see it, maybe not very clearly, but when we add the whole mixture into a separatory funnel, you will be able to see the two layers very easily. So you transfer the entire mixture into the separatory funnel and make sure that you do not add the boiling chip. Boiling chip should remain behind. Otherwise, it's going to clog the separatory funnel. Now you can see the two layers. The upper layer is distinctly, the clear layer is N-butyl bromide, and the lower layer is concentrated sulfuric acid. Now you are basically interested in the product, which is the upper layer. So lower layer is useless for you, so you can drain it into a beaker. Drain the sulfuric acid into a beaker by opening the stopcock partially. Make sure when you're getting very close to it, the draining should be very slow. Okay. Now you want to wash it with 9 molar sulfuric acid. 9 molar sulfuric acid is used to absorb any leftover butyl alcohol. Hopefully there won't be any leftover, but just in case, if you have a leftover butyl alcohol, you want to wash it with the 9 molar sulfuric acid. 9 molar sulfuric acid will not dissolve your butyl bromide product, but it will dissolve only the leftover butyl alcohol, if there is any. So we're basically just washing it to get rid of any leftover butyl alcohol, and you put the stopper on the secretory funnel and then you shake it. You can you can really shake very hard if you want to. It's a good idea to shake hard. You can also shake it by inverting the separatory funnel and bleeding to make sure that if there is any organic vapor that are developing any pressure. So it's a good idea to bleed the separatory funnel by inverting during shaking. Okay, you put it back into the ring stand and let the two layers separate. You remove the stopper and wait till the two layers become distinct again. Now the lower layer is again heavier than your product, so it's the lower layer is sulfuric acid non-molar and the upper layer is your product. So you again want to drain the lower layer into the same beaker where you had drained off the sulfuric acid in the previous operation. This is your upper layer, organic layer. This is your product. You got to save it. Now it has sulfuric acid contamination. Most of its product, but a little bit of sulfuric acid. So you want to wash it first with water and then with sodium bicarbonate solution. First water. So add water. And put the stopper back and again shake the separatory funnel the way you did it before while bleeding. Don't forget to bleed occasionally, and put the stopper back, close the stopper and open it, close it, open it, close it, right? That way. Now you see the two layers. This time the upper layer is water and the lower layer, which is the milky layer, is the product. So you got to follow the product, not water. So you need to isolate the lower product this time, lower layer. So drain off the lower layer into a clean beaker. This is your product. You can drain it while putting it in the ring stand or while holding it between your hands. That's okay. Alright, so this is just water, so you can mix it with the sulfuric acid fraction. Now this will be discarded in the proper waste container in the hood. Your product is in the beaker. This has now a little bit of acid may have left, so you need to wash it. We need to put it back into the separatory funnel and wash it with baking soda, sodium bicarbonate solution. Sodium bicarbonate is a mild base and it will get rid of the residual sulfuric acid very easily by reacting with it. It will neutralize it, produce a little bit of gas, carbon dioxide, and now sodium bicarbonate sometimes give you some emulsions when you shake hard, and usually emulsions are troublesome, but in this case you can separate the layers nicely by opening the stopper and swirling the separatory funnel. Swirling helps in clearing the emulsions. You just leave it there for about a couple of minutes and the emulsion will be gone. This is not a troublesome emulsion. These are just bubbles. Slowly they will merge into the upper phase, and you will be getting two clean layers uh, in about 5 minutes. Okay, you drain off the lower layer. Again, the lower layer is your product. Upper layer is sodium bicarbonate, which is lighter than your product. Now this has only moisture, residual moisture in there, so you know how to get rid of residual moisture. You add anhydrous sodium sulfate and swirl it and let it stand for about 5 minutes. So what will happen is anhydrous sodium sulfate will get rid of the moisture, and it will leave very clear product. Now you take a tiered flask and transfer your product into the tiered flask, and all you got to do is now just make sure you leave the sodium sulfate behind. Only the liquid should be transferred. All you got to do is now just reweigh the flask and find out the mass of the product and the yield. Okay, so now we are going to calculate the yield. For this you need the mass of the E flask, which is 32.14 gram. And mass of the flask plus product 41.64 gram. You subtract the first number from the second number, and you get 9.47 gram of the product. That's the product that you got. So you want to find out the yield, and before you find out the yield, you need to find out the limiting reagent using two-dimensional equations. All right,